So people look at SNPs. How many people here, read a study on a certain SNP and they saw that the risk of something was higher? So these studies are almost illegitimate, right? It's something I learned as well. It's because the impact of each individual SNP is very small. These variants, they're picking up a lot of other things, right? So usually the study's done certain ethnicity, with a group of people that are similar in some ways from a certain town in some random place. And also people inherit variants together, so you're also looking at what are all the other variants that are associated with this variant. What ends up happening is these risks are very overinflated, and what you end up getting is a lot of contradictions of like one study says that this is associated, another study says it's not associated, and anyone who looks at a lot of SNPs and genetics papers will see the number of contradictions, which make it very complex, which is why individual SNPs are not very predictive. Which gets you to polygenic risk scoring. So the way that genetics needs to be carried out is what's called polygenic risk scoring. And what that does is it teases out actually the causal variance. So in order to do a prediction, you actually need to understand, you have to, like if you're taking certain variants, you have to exclude other variants that are just connected. It's called linkage disequilibrium. There are these variants that are just connected to the main variant that you're looking at because they were inherited together. So in order to do the polygenic risk scores, you need to figure out the cause just from an association. You also need to look at thousands or millions of variants because each variant is going to have a small impact. So it takes care of the double counting issue, because if you have two variants that both have 50% increased risk, but they're actually just 100% correlated with each other, there's no increased risk. And if it's 99% correlated, then you have to take out that double counting. And then you also need a very large data set to validate those models to make sure that the polygenic risk scores are accurate for each model that you're testing, for each condition. Other methods are just not legitimate. The difference of the impact between these approaches are at least 10x.